Right, time for the main part. It is time for the main course. Bon appetit, because you're about to learn today character movement. In this video, we're going to have our character go from idle to the running animation, which is going to trigger our character to move, and we're going to have the WASD keys to move in all directions. And then when we stop running, our character is going to transition smoothly back into the idle position. First things first, select your character mature, go into the dope sheet, and then go into the action editor, and you're going to want to have your complete run animation already ready. From the idle position, transitioning into the run cycle loop, and then transitioning back into the idle pose. Now before you go, oh, what do you mean I already have a complete run animation? Are you supposed to be teaching up? As I've already mentioned, this is not an animation tutorial, so no, I will not be teaching how to animate the run cycle in this video. However, before you explode, you'll be happy to know that I have given away this run animation for free, so you can download it right now if you don't already have your own run animation. And not only am I giving away this run animation, but I'm also giving away all the animations that I've made for this character in these tutorials for free, as well as this base character model and its armature rig as well for free. If you're watching this on any social media platform in which there's a description box, I've put the link to those in there, so if you want it, you can go ahead and get it right now. However, if you've made your own run animation, you're going to go ahead and separate it into 3 separate animations. The first animation being the idle to run animation, which is the section of the run where the takeoff is, up until the first frame of the running animation loop. The second section being the run animation, which is the run animation loop itself, from the first keyframe pose of the running animation to the end, which loops back into the first. And the third section being the run to idle animation, which is the section from the end frame of the run loop back into the first keyframe pose of the idle animation. And also make sure each of the separate animations that you've made start at frame 0. The way you move around and delete keyframes is essentially the same as how you would move around and delete objects. However, as a quick rundown, you can select each one individually, press A to select everything, or if you want to select the entire column, press the keyframe at the top of the dope sheet summary row and select the entire column. You can box select them, circle select them, and you move them around by pressing G and moving your mouse to move them anywhere you want. And whenever you make a new animation, it copies the one that you're currently viewing, and then you can choose to either delete all the keyframes and start afresh, or edit the keyframes in this new copied version. And pressing the F button beside the animations makes sure that the animation doesn't delete itself if there's nothing currently using the animation. I tend to do this for all my animations because the last thing you want is to work hard on one, and then the next time you load up your project it disappears because it wasn't assigned to an object, and thus it never got saved. It's pretty frustrating, and this prevents it from happening. So after you've separated each section of your run animation into 3 separate animations, it is now time to make our character play the run animation upon pressing the WASD keys in the game. Obviously starting with the idle to run section first. So for this, select your character mature, go into the logic editor, and add 4 keyboard sensors. First one's going to be the key that will make our character run forward. The second one's going to be the key that will make our character run left. The third one is going to be for the right, and the fourth one is going to be for the back. For forward, we'll be pressing W. For left, we'll be pressing A. For right, we'll be pressing D. And for back, we'll be pressing S. Turn the true triggering on for all of them, and then minimize them all. Connect them all to our character idle Python controller, then add another action actuator called idle to run, which is going to have our idle to run animation. Turn the continue off, and get the end frame of your idle to run animation, which for me is frame 25, and then make a game property for it so we can have access to the frames of our animation when we're doing the programming. Connect that to the Python controller, and then we're also going to add a state actuator and set it to state 2, as that is the state where all our programming for the running state is going to be, since state 2 is going to be our run state, and then also connect that up to the Python controller. So we have our keyboard sensors hooked up to the Python controller, and very soon we're going to make that activate the idle to run animation and put our character mature into state 2, which is the running state. So minimize those actuators and go into the text editor, and we're going to add the sensors and actuators we just made into our script here. So make a new section called inputs, and this is where our sensors are going to be. So for the forward sensor, give it a name like forward, and then afterwards we type equals, and then type cont sensors, which means the controller's sensors, and in the square brackets and quotation marks, type in the name of the sensor, which is forward. Do the same for the left, right, and back sensors, like so, and then make definitions for our action actuator, which has our idle to run animation, which we're going to put under the animations section, and then our state actuator, which we're going to make a new section for called states, and give it a name like state 2, and then cont actuators, which means the controller's actuators, and then put in the name of the state actuator, which is 2 run state. Now we want it so that if any of the WASD keys are pressed, the idle to run animation and the state 2 actuators activate. Now we could make code blocks for each of the individual keyboard sensors, so for example like this for the forward key, and then do the same for the left, right, and back. However, that is way too long, and generally it's better to have scripts as simplified as possible. Now you could write it like this using OR in your statement, which will have the entire action under one block of code, and you would be right to do this. However, an even better way is to have the entire statement after the if summarized in the definitions section of our script like this. Therefore, when making it happen in the script, we only need to type in one word, which is the definition we gave to the entire statement. And since this is effectively everything we need for our run system from the idle state, we can label this run system. We will also want our character controller to go into state 2 as well, since it and the armature need to always be acting in unison for them to be effectively operating with each other. Therefore, the character controller is also going to have an idle state and a run state, and for this we'll need our script connected to our character armature to send it a message telling it to go into state 2. And this is where, for the first time, we will use a message line. In the BGE module, message lines consist of 3 different components. The first is the message text itself, which the object we want to send the message to will read, in which you can write in anything. The second section, which I'll be very honest with you, I don't know exactly what it does or what it means. However, in my experience, I've never needed to, and I always leave it blank. According to the documentation, it's the body of the message, however, that. And the third section is where we put in the name of the object that we want to send the message to. So in our case, for the first section where we put in the message, we can write something like run state. Leave the second section blank, and in the third section for the name of the object that we want to send our message to, we will write in the name of our character controller, which for me is character controller. So now that our script is sending a message to our character controller, we can go into the character controller's logic editor and get a message sensor that will receive the message. For easy reference, give it the same name we gave the state actuator in the character's armature, add a state actuator and copy the name there too, connect them up, and in the actuator set it to state 2. So when the character controller receives the run state message, it activates the controller, which activates the state actuator, which we set at state 2, making the character controller go into state 2. Click the I button to see the state changes in the game, and now if you run the game, as you can see, when you make the character run, both the character controller and the character's armature go into state 2, as they should when entering the run state. Now to implement the run cycle section of our run animation when our character is in the running state. For this, we're going to have it so that in state 2, the character armature is always playing the run cycle loop. So select your character armature and go into the logic editor, go into state 2, and we're going to need our always sensor. Since we already made that in state 1 for our idle state, we can get that into state 2 by unchecking the state box in the sensors, which will allow us to have access to all sensors across all states. Add a Python controller and connect it up. Then add an action actuator for our run animation, get the end frame, which for me is frame 43, and make a game property for our run animation. Set the priority super high like 99, set the playback type to loop stop, and then connect the action actuator to the Python controller. And now that we have everything we need for our run animation to play, go into the text editor, make a new function, and we're going to name this run with an open close brackets and colon. Then copy and paste the first 4 definitions from the code and our idle state, and then underneath add the sensors and the actuators that we've just connected to the Python controller in state 2, which for now is just a run animation. Since this is an always sensor, which is always sending an input to activate the controller, we don't actually need to put that in. So just put in the run animation that we've made. And since this is all we need to have a run animation play, we can simply just have the controller activate the run animation with no need for any if statements, just like so. In the logic editor, change the script type to module, and have the names of this section of the script be applied to our Python controller. And now if you run the game and test it out, we now have the running section done with the character transitioning seamlessly, nice and smooth, from the idle into the run animation. And now for the run to idle section. For this, we're going to have it so that if you stop pressing the WASD keys, both the character armature and the character controller will go back into state 1, which is the idle state. So first, we're going to select the character armature, go into the logic editor, and get the actuators we need to transition back into the idle, which are the WASD keys, since we're going to need to know when they are no longer being pressed, an action actuator for the run to idle animation, and a state actuator for us to go back into state 1. So for the action actuator, name it run to idle, and get the run to idle animation, turn continue off and get the end frame of the run to idle animation, which for me is frame 91, make a game property for it, and then make that the frame property, connect that to the Python controller, and then in the state actuator, make sure that state 1 is selected. Name this 1 for state 1, and then idle state, and then connect that to the Python controller as well. Connect up the WASD keys, and now we have the sensors and the actuators that we need. Go into the text editor and add the new sensors and actuators that we've just made. And we're also going to need the same run system we made from the code in the idle state, because with this we're going to be detecting if any of the directional keys are not pressed. Make a new section called run to idle, and underneath we're going to have it so that if the directional keys are not pressed, by typing if not directional keys pressed, then our controller is going to activate the run to idle animation and the state 1 actuator. And as these are actuators, make sure you deactivate them after they are no longer active. And remember, our character controller also has to be sent back into state 1, so we need to send a message for it to also do so. So underneath the if statement, type message. For the first section, type something like idle state, put a comma, leave the second section, put another comma, and in the third section, type in the name of the character controller, which for me is, well, conveniently enough, character controller. And now to make our character controller receive the message, have our character controller selected, go into the logic editor, go into state 2 where our character controller will be when it receives the message, add a message sensor to receive the message, and copy the idle state message into the subject box. Give the name of the sensor the same name as we gave it in the character mature for easy reference, and then add a state actuator, select the first state, copy the name of the sensor into the actuator, and then link them up. Now our character controller will receive the message that we sent it from the script, which will activate the state actuator, making it go back into state 1, just like our character are mature. Therefore, now if we press P and run the game engine, if we're running and we let go of the WASD keys, our character ever so seamlessly, ever so smoothly returns back into the idle state. Now, two quick things we can do to improve this a little more is we can first have the transition animations blend in more when they're played, and we can do that by going into the action actuators of our idle to run and run to idle animations and increasing the blend in value to however many frames we want it to blend. Usually a good rule of thumb is however many frames between the first and second keyframes of the animation, or sometimes if the distance is too short, the first and the third keyframes of the animation. However, you can always tweak it from there, or if in doubt, just put 5. 5 is generally okay in most cases. So do that both for the run to idle and idle to run animations. And now, very nice. And the second thing is we want the frame the animations are at to be reset back to 0 when they're not being played. This is crucial for a lot more reasons than there would be for me to have the time to explain them all in this video. One huge one being that if you have any keyframes in your animation higher than 0 trigger anything, they'll still be doing so even if the animation is not playing, if the animation property is not reset back to 0 when it is not playing. If you press the I button on all the animation game properties and run the game, you can see that this is currently not the case, so we should fix this. So go into the text editor and make a new section under all your definitions called resets, and for all of those, we'll be resetting them all back to 0. This won't be the idle animation since it's continuously looping in the idle state. However, this will be the idle to run animation since the moment it gets played past frame 0, it is already in state 2. Thus, it is never really playing in state 1, and as we mentioned, if it's not playing, we need to reset it back to 0. So to reset our game properties to 0, go into the text editor and type own, which if you remember means the controller's owner, referencing the object the controller belongs to, which is the character armature. And now that we've referenced the character's armature, from here we can open up the square brackets with the quotation marks, and in the quotations, put in the name of the game property. So idle to run. This is how you access the game properties of an object the script is being ran by. And to reset the value of the property to 0, we just put equals 0. Now in the idle state, when this section of the script is running, the idle to run animation is always going to equal 0. I'll do the same for the run animation game property since that is ran in state 2 and not in state 1. However, don't do the same for the run to idle animation because while that is activated in state 2, the animation actually plays in state 1. Now we're ready to scroll down and do the same for the code in the run state. So make a reset section here as well and reset the idle animation and the run to idle animation since those animations are not playing in state 2 and thus need to be reset back to 0. Now for the idle to run animation, we want that to reset to 0 once that's finished and the run animation starts playing after. So for that, in the run section, we'll be making a new if statement. And for this, you're probably thinking, if not own run equals 0, then own idle to run equals 0. And yeah, you're technically correct, and that would work. Of course, with the exception of the fact that with if statements, you have to use double equals for the equals to work. But it's a lot cleaner to do it in the way that I'm about to show you, which is to make a new section in the definitions called animation properties, and then make one for your run property, which I'm going to call run. And then now that we have that in the if statement, we can write if run is not equal to 0 with the exclamation mark expression instead, which is a cleaner way of saying not equal. This is going to reset the idle to run animation back to 0. And if you run the game and you check, as you can see, it works. In the next section of this tutorial, we finally have our character actually move during each of the sections of the run animation. So beginning with the idle to run section, if we go into the animation for it, we want our character to move forward during this step forward part and to shoot forward during this takeoff part. And our character is going to be moving at different speeds during both parts. Slower for the step forward and faster during the takeoff. Obviously, this is going to depend on your animation, so if you're using a different one, make those decisions based on that. And to make it happen, we're going to have the frames of each of those parts of the animation telling the character controller to move forward. So hop into the text editor, add the idle to run animation game property to our animations property list, then make a new section above the run section called idle to run, and add another section underneath it called motion. And this is where we're going to have our if statements to which we'll be sending messages to the character controller for it to move. So with that being said, let's do the step forward part of the idle to run animation first. And for this, we're going to want all the frames from frame 1 to frame 14. Therefore, if the idle to run game property is more than or equal to 1, and also less than or equal to 14, then we're going to send a message saying idle to run motion 1 to the character controller. Now for the second part of the idle to run animation, which takes place from frame 15 to frame 25. So underneath, make another if statement and have it so that if the idle to run animation is between 15 and 25, then it is going to send a message saying idle to run motion 2 to the character controller. And now that we have our messages telling the character controller to move, we can have our character controller receive the messages, to which upon receiving them, it is going to make the character controller move with the motion actuator. So have your character controller selected and hop into the logic editor. Make sure that you're in state 2 and add 2 message sensors that will receive our messages. Copy and paste each message into the subject boxes. Name the first one idle to run motion 1, and then name the other one idle to run motion 2. Minimize them all, and then add 2 motion actuators. Name the first one idle to run motion 1, and the second one idle to run motion 2, and then connect the idle to run motion 1 message sensor to the idle to run motion 1 motion actuator, and the idle to run motion 2 message sensor to the idle to run motion 2 motion actuator. If you've already watched the RanGE logic and Python tutorial that I made, you'll know exactly how the motion actuators work. So bing, and bing 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 for the motion 2 actuator. So now if we minimize those, run the game and make our character run, the motion for the idle to run section of the animation is now in the game. And we just need to do the exact same for the run section and the run to idle section. So with that being said, above the if statement, make a section called motion. And then under the if statement, send a message saying run motion to the character controller. Then select the character controller, go into the logic editor, make sure you're still in state 2, add a message sensor to receive the run motion message, and copy the run motion message into the message sensor. Name the message sensor run motion, and then add another motion actuator, also called run motion, and set the speed that you want it to move. Wapow. Connect the run motion message sensor to the run motion actuator, and the run section is now done. But hold up, there's one more thing, because if you look at the if statement, the condition is if the run animation property is not equal to 0, then it's going to move the character controller. However, if we look at our run animation, it loops from frame 0 to 43, and this, my friends, would be a big issue since we don't want the character controller to stop moving every time it loops back to 0 for 1 frame before moving again. So to solve the issue, we're just going to have it start at frame 1 instead. Problem solved. Press B and take a look at the run, and as you can see, off he goes into the abyss. Now, probably wondering, why did we just get left behind? Isn't our camera supposed to be following our character? And yeah, it is. So to make that happen, and I know what you're thinking, what we're not going to do is parent the camera look empty we made a couple tutorials ago to the character controller, because if we did that and the character controller rotates, the camera also rotates, and we don't want that, because we want the character controller and the camera to be able to rotate independently from each other. So instead, we're going to parent the camera look empty to a single vertex inside the character controller. Since when an object rotates, the individual vertices themselves do not rotate, they merely change location, which then gives the object the appearance that it's rotating. So select your camera look empty, press Shift A and snap the cursor to the selected object. Then select the character controller and go into edit mode. Select any one vertex, duplicate it, and then with it still selected, press Shift S and then snap the selection to the cursor with the offset. And then now when we parent the camera look empty to the character controller, we're going to press Ctrl P to parent, and then instead of object, we're going to click vertex. And what this has done is parented our camera look empty to the vertex that we've created in the character controller. And the reason why we made a whole new vertex in the character controller at the position of the origin point where the camera look empty is because when you parent an object to another object by vertex, it's going to try and find the nearest vertex to parent to. And you know, while we're at it, get the sun lamp and also parent that to the character controller with vertex parenting, so wherever our character goes, it can keep the shadows. Since if you select the lamp and go into the data properties and scroll down and click show shadow box, the shadow box by default is not actually that large. And for all objects outside the shadow box, the shadow is just not going to be rendered. This has its benefits since it saves on game performance. However, since our camera is always following our character, we're going to always want to see the character's shadow. But of course, you can also increase the size of the shadow box by scrolling down and increasing the frustum size and also increasing the clip end. But anyway, back to our character. If we now run the game and make our character run, now we will never be left behind ever again. And now it's finally time for us to apply the movement to the final section of the run animation, the run to idle section. Since our run to idle animation plays when we've transitioned our character back into state 1, we want to send the messages to the character controller for the movement of the run to idle animation in the idle section of our script, which runs in state 1. So to do that, first let's make an animation property section in the definitions, as this is where we're going to be putting the run to idle animation game property. Afterwards, scroll down and make a new section for the run to idle, and here we're going to be sending messages to the character controller to move in the exact same way we did for the idle to run section. So make a subsection called motion, and for our run to idle animation, we want our character to slow down according to the feet movement of the animation. So our character does this quick little scurry over here until frame 17, and then he begins a slightly longer step in which he would have slowed down at around from 17 to around frame 25, and then from there until frame 65, a much more slower step until his ankle reaches where it is in the idle position to which he would have stopped moving. So I'm going to time lapse this, and as you can see for the messages, I'm putting run to idle motion 1, run to idle motion 2, and run to idle motion 3. And now that we have our messages to our character controller, we can now select our character controller, go into the logic editor, make make sure you're in state 1 since the run to idle animation is in state 1. And by now you should be starting to get the hang of the workflow here, which is to add message sensors for each of the messages being sent, have the character controller receive each message, name the message sensors like the messages for easy reference, get your motion actuators, copy the name of the sensors to the motion actuators, apply the values. For mine I put negative 0.11 for the first motion, negative 0.08 for the second motion, and 0.01 for the third motion. Also, what I found to blend the motions together a little bit nicer is to have a little bit of linear velocity and turn the local coordinates option on just like the location row, and then connect each message sensor to the motion actuator it's supposed to activate. Minimize them all. And now if we take a look and we make our character run, our character now runs, however he runs just in one direction, which leads us into the final step, which is for us to be able to control the direction the character is running in using the WASD keys. So to do that, nice and simple, we're going to go into the viewport, select the character controller, press Shift S and snap the cursor to the selected object. Then we're going to add an empty and move it along the Y-axis so that it's in front of our character, round about where the end of the grid is. Then, with your 3D cursor still in the same place, we're going to change the pivot point to 3D cursor. And then with our empty still selected, we're going to press Alt-D, right click to reset the location. And then we're going to rotate this 180 degrees by pressing R 180. Then we're going to select both empties, press Alt-D to duplicate them, right click to reset their location, and then rotate them on the Z-axis again 90 degrees, therefore giving us empties to the front, left, right, and back to our character. And then finally, we're going to select all 4 of the empties we've just made, press Alt-D to duplicate them, right click to reset their location, and then rotate them on the Z-axis 45 degrees so that the position of the new empties are halfway between each of the original 4 empties. So now we have a front, left, right, and back empty, and a front, left, front, right, back left, and back right empty. Select all of them and parent them to the camera look empty. And basically what we're going to have here is we're going to have our character controller face each one of these empties in the direction of the keys that we're pressing in. For example, if we press the left key, our character is then going to face the empty on the left. And if we press the forward key, our character is going to face the empty in the forward direction. So the one in the front is going to be face front. For the one on the left, we're going to be naming it face left. The right one will be called face right. The back one will be called face back. The front left one will be called face front left. The front right one will be called face front right. The back left one will be called face back left. And the back right one will be called face back right. Go into the character controller's logic editor, and in the running state, prepare the message sensor which our script is going to send the message to. And we're also going to need to prepare the actuator that will make our character controller track whatever object we tell it to, which is going to be the edit object actuator and the track to mode in the actuator. Leave everything blank in the actuator since we're going to be using the script to directly control everything when it is being activated by the message sensor. Name them both track. Since we have our message sensor prepared for the message we're going to send it, and our tracking actuator which is going to make our character controller track the empties, we now have everything we need to move on to the coding. So go into the text editor, and in the code for the run state, add a new section in the definitions called objects. And it's here we're going to give our script access to the character controller directly, so it can access the track actuator inside it, when it's activated by the message sensor, which we're about to have our script send a message to. So in the script, for our character controller, name it something quick like CC, and then to get it, type scene.objects, and then the square brackets and quotation marks, pull in the name of the character controller, which for me, Next we want to define the track actuator inside the character controller. So in the script, call it something like track, and then to get it, we're going to go into the CC's actuators. And then in the square brackets and quotation marks, pull in the name of our track actuator, which is track. Make yourself some headers for these so that they're easy for you to understand. And now we're ready to control the character controller's track actuator with our script. So under the run section, make a new section called faces. And what we're going to have here is if any of the WASD keys are active, that's going to send a message to the character controller, activating the track actuator inside it. And along with that, we're also going to be writing code controlling the track actuator, telling it what object to track, how long it takes for it to track the object, the axis of the character controller it will use to face the object while it's tracking it, and whether it tracks in 3D or not. So the first object we want it to track is the face front empty when we press the forward key. So make a header called forward, and then underneath it for the if statement, we're going to type if the forward key is positive. We're going to send a message saying track to our character controller. Copy the track message into the message sensor we made in the character controller for it to track the track actuator. And then underneath it, we're going to get our track actuator, so track and then dot. And with this, we are going to control each of what we need to control in the actuator. So the first is the object, and to access that, after the dot we write object and then put an equals, open the quotation marks, and then in the quotation marks put the name of the object that we want it to track, which is the face front empty. For us to control the time, type track, after the dot put time, and 5 frames is enough to give us a smooth enough transition, so put 5. For the track axis, after the dot put track axis, and for this one, yeah, it's not as simple as typing x, y, z, negative x, negative y, or negative z, because the value type for this is an integer, aka a number. Therefore, the x, y, z, negative x, negative y, and negative z axes are actually all assigned to a number from 0 to 5. As you can see over here, the x-axis is 0, the y-axis is 1, the z-axis is 2, the negative x-axis is 3, the negative y-axis is 4, and the negative z-axis is 5. So if we look at our character controller and change the transformation orientation to local, as you can see, our character controller is facing forward in the negative y-axis, and as we know now, the number for the negative y-axis is 4. Hence, that will be the axis it uses to track the empty. And then at last, for the 3D toggle, it's pretty simple. We type use 3D, and this is straightforward since we only need to type either true or false. True if we want to track an object in 3D, and false if we want to track an object in 2D. In this case, we just want to be turning to track the empties horizontally only, thus tracking in 2D. And now, we just need to do the same for the other 7 directions. So do the same for the left, right, and back, and for those you're going to have the track objects be their face left, face right, and face back empties. And then for the diagonal directions like front left, front right, back left, and back right, you're going to have it so that, for example, for the forward left direction, if the forward is positive and the left is positive, then it is going to track the face front left empty. And yeah, do the same for the rest. And now, if we run the game and press the WASD keys, our character controller will now face the empty in that direction. And since the empties are parented to the camera look empty, even if the camera rotates, the directions are still going to be the same from the camera's perspective, just like most character action games. Therefore, if you're facing the left of the character and you press left, your character is going to run left from the perspective of where you're viewing the character from. Same if you're looking at the character from the right perspective and you press left, the character's going to turn around and run to the left. And there we have it. We have our character movement system in place. Look at us. Look at this. This is AAA. Easy. Game of the year right here. It's pretty nice. Alright, now this tutorial took 7 hours to record. 7 whole hours. That is crazy!